What's up, everyone? This is LeetCode 572, subtree of another tree. We've done this problem in Python, now we're doing it in C++. This problem statement is a little bit wordy. You can read it if you want, but basically what we're going to do in this problem is we're going to check in this tree here, is there a subtree that is basically the same as subroot? And what does same mean? It means structurally it's the same, and also the node values are the same, right? For example, right, this subtree here in root is the same as subroot. Why? Because structurally it's the same, right? We have a node with a value 4 with two child nodes, right? 1 and 2, 1 and 2, right? So subroot does exist in root, and we'd return true. Here, for example, this would be an example where subroot doesn't exist in root, right? Because technically we have this subtree here, but again, we have to handle the entire tree from a given node. So we start at 4. It has 2 child nodes, right? Subroot also has 2 child nodes, but this 2 has a child node, whereas in subroot, this 2 does not have a child node. So structurally, it would not be the same, okay? And so we would return false here. Okay, pretty simple. Hope that made sense. So how are we going to handle this? Well, first of all, let's handle edge cases, right? So let's say root is null and subroot is also null. In that case, we can return true because if root is nothing, then subroot is nothing, then technically subroot does exist in root. I know it's a little bit weird to think about, but right, if they both don't exist, then technically subroot does exist in root. Now, if we have a case where root exists but subroot doesn't, or subroot exists but root doesn't, that'd be a problem, right? So that would be a case where we have something like this, right? And obviously we'd have to return false. That'd be a bad edge case. Now we need to check at a given point in. So when we're basically going through, we have this tree called root, right? When we're basically checking at a given point the given subtree, we need to basically check, is this given subtree the same tree as subroot? So we need to write a function to check that, okay? So we're going to call that function is same tree, right? And we can make that up here. Okay, and now take in value p, the value q. Again, you can call it root node, subroot node, whatever, doesn't matter. I'm just gonna call it p and q. By the way, there is a problem on LeetCode. I don't remember. Actually, let me look it up, because there is a problem that we've done before, called is same tree, and it's very, we're basically using that same approach for this problem. That would be LeetCode problem 100. So I would do that problem also. It does help. In that problem, we're just given two binary trees, and we have to check if they're the same. And again, we're doing this, we're basically checking if 2 trees are the same, except we're not doing it on the entire tree versus the entire tree. We're doing it on a subtree of this tree and the actual other tree, which would be subroot. Okay, so it's very similar, but a little bit different. This problem is a little bit different. Okay, so if we have p not existing and we have q not existing, that is a good thing because that means they're structurally the same, right? Now, if we have p that doesn't exist, or q doesn't exist, that'd be a case where p exists but q doesn't, or q exists but p doesn't. That would be bad, so we'd want to return false. Additionally, if we have a case where the value of p is not the same as the value of q, that is also a bad, that is also a problem and a bad case, so we'd want to return false. I'll give you an example, right? When we're at this 2 and we go left, let's say this is p and this is q. When we go here, when we go left, p would technically exist, right? P.left would exist, but this would be the new p, right, recursively. So this p does exist, but this q right here would be null. So structurally, they would not be the same. which is actually why it's false in this example, right? So we'd want to return false. Or another case, right? P.val, Q.val. This part here is like, let's say this was a 2 and this was a 3. Obviously, how can this subroot exist here if the values are different, or if it's structurally different, right? So yeah. And then down here, we're basically going to continually keep checking if it's the same tree on the left subtree and the right subtree. Assuming if no problem is if we ran into no problems with like P and Q, right? So for example, we do P.left, Q.left, and is same tree, P.right, Q.right. This would be a case like, let's say we're at this 4 here, and at this we're starting at this tree here, or sorry, up here. We're starting at this 4 and we're starting at this 4. Well, P and Q are not null, so we don't handle any of this, and they also are equal to each other, so we don't go in here either. And so that's basically, they're structurally the same so far, and the values are the same, so we keep checking on the left subtree, on the right subtree, right? And we keep doing that until we either hit a point where basically we went through all the nodes because we're returning true, or where we return false because let's say P exists and Q doesn't, or Q exists, P doesn't, or the values are not the same, right? So yeah, this is basically just checking if the trees are the same, right? Obviously, that's what the function is called. Now, if we return true, then we can return true down here, right? And also, we can keep recursively checking on this subtree. Okay, and so we're going to say root left, whoops, subroot, or a subtree. Okay. So basically we're checking, we have this root tree here, okay? And we want to check, does this subroot exist in this tree, right? That's what we're trying to find out essentially. We start here at the root node, right? And we check, okay, 3 and 4, okay, those are not equal. So let's basically move on to here. And this is where the current subtree that we're looking at, right? Because we're going left here. So we're checking here. We were basically continually checking, but our subtree along the way until we find it is continually shrinking, right? Meaning this is initially our entire subtree, then this is initially our entire subtree, then this is initially our entire subtree, and we keep shrinking these subtrees until we find whether subroot exists in somewhere in this tree. And if it doesn't, then we would return false. But if it does, we return true. That's why we have this or here, because we only need to find if a tree exists in here that's equal to subroot only once, right? Anyways, pretty simple. Again, I'm sorry if I didn't explain it too well, but I think this is not too difficult. Oh, this is not a capital. This is not a capital. My bad. Yeah. Again, I don't think this problem is too difficult, but if my explanation was not that great, then let me know. I can explain in a comment or maybe make a video update again, but I think this problem is pretty simple. Just make sure you do this problem, LeetCode 1, whatever I said, 100 or whatever it was. But yeah, I hope I explained it well. I think I did, but if you have any questions, just let me know.